Good morning, students. So, chemical bonding and molecular structure. Okay. So, we have started with chemical bonding and molecular structure. Okay, na? So, yes. Good morning to everyone. So, with respect to last class, I have just introduced about chemical bonding, right? So, what and all concept we are going to discuss. I have just introduced. ಹಾಗಾದರೆ can any one of you, which is that first concept we are going to discuss? 1 minute. Now, sir, board is blur. Okay. So 1 minute, I will write. Just tell me why bonding is necessary. Okay. So now it's visible. Okay, not clear. Fine. Now it's clear. All of you. Now it's visible. I think network got stabilized. Now it looks like it's clear. No. Now at present, whether it's clear. Okay. So it's blur. Okay, 1 minute. One minute, students. 1 minute. Lens has to be clean. Now, just tell me whether it's blur or it's clear. Yes or no. No means it's blur. Yes means it's clear. Just tell me. Okay, now it's clear. Yes. For all of you. I'm telling yes.
Okay.
It's clear. Okay, done. Top is not visible.
Okay. But this thing you see that side is okay. Fine.
Okay, so shall we start then?
Your pen is okay.
I have changed the pen. It was that, now it's.
You have put two pens or no?
I have kept all the pens in there. So I will use, sir. Okay, we will start. 1 minute. Okay. So done. So we will start. So I think there was a network issue. I cleaned lens. That might be the reason. Okay. So fine. So in that case, why bonding is necessary? Why a element has to make interaction with another element or same element? Say for example, I have oxygen atom, right? I have the oxygen atom, which we represented by O, right? Which we represented by O, symbolic representation for oxygen atom. Now in the nature, oxygen will not be present as O, it will be present as O2, okay? So at room temperature, it will be present as oxygen, which will be gaseous in state, O2. Yes, oxygen molecule. Yes, Roha. So that's where at room temperature it will be present as oxygen gas, which we are going to inhale, right? Which we are going to inhale during the respiration. Same way, if I take fluorine, atom, symbol is F, 1F, okay? But at room temperature, once again it will be present as F2, okay? In gaseous state, F2, right? Same logic is applicable for chlorine, same thing is applicable, right? Now same way, if you go to the carbon, carbon atom, symbol is C, but in the nature, this carbon can be present as coal, right? Or we can call it as a modified form, coke, or whatever it is. In all these cases where we have multiple carbons which will be interacting with each other, like diamond and all. So where multiple carbons, they will be interacting with each other, right? Now if I go to the metals, if I take sodium, atom symbol is Na, but if I go with sodium in the nature, it will be present as a soft solid. So where multiple sodiums, they will be interacting with each other. Right? So what I mean to tell here is, except inert gases where we have helium, which will be present in the nature as helium only. We have neon, which will be present in the nature as neon only. Or we have argon, which will be present in nature as Ar, argon only. No multiple molecules, single atom. So therefore, when it comes to inert gas, they will be present in the nature at room temperature as monoatomic gases. That are these are the elements which will be present in monoatomic form. But if you take majority of the element, they are not present in the monoatomic form. They are interacting with each other. That's where we have the molecules. That's where we have the concept called as molecules, where oxygen is interacting with oxygen, fluorine is interacting with fluorine, sodium is interacting with sodium, or carbon is interacting with the carbon. But story which will not end up here. Further, we have a compounds which can be called as a molecule. We have the compounds where one element is going to interact with the another element. That's where we have the water molecules. Right? So carbon can interact with the oxygen, two oxygen, that is carbon dioxide. So that is nothing but carbon dioxide. Now carbon dioxide, once again a compound. Once again a compound. So what I mean to tell here is, in the nature, either atom is going to interact with another atom, or an atom is going to interact with another different atom. Once again I will make it clear. In the nature, an element or an atom is going to interact with another same atom or different atom. Okay? But they are not present in their monoatomic form, except inert gases. Except inert gases. So therefore, we have a scientist called as Lewis, who has contributed towards this in answering why a molecule has to be formed, why an element is going to interact. Yes, good morning everyone. Yes, Vishwas, okay? So that's where we have the interaction, which was well explained earlier by Lewis. He thought that atom will be a positively charged kernel. Positively charged kernel. So kernel means core, a very important core. That's what the kernel talks about. Vishwas, yes, good morning. Okay, na? So that's where kernel means what? It is nothing but a positively charged core element. Okay? So Lewis thought that atoms will be a positively charged kernel which will be surrounded by valence electron. ಹಾಗಾದ್ರೆ what this kernel will be composed of? This kernel will be composed of nucleus and inner electrons. So that's what he thought about. Okay? Yes, Rakesh, I will come to that. Before that, we have to explain about Lewis, because he is the one who gave one particular theory or one particular rule. Okay? So the atom will be positively charged kernel, and in that case which will be surrounded by valence electrons. Now what is that kernel will be? Kernel means, in actual, kernel meaning is core region. So that will be composed of nucleus and inner electrons. Okay? Now, if you imagine a cube, that's where we have a cube. Now, we will imagine kernel is present in the core of this particular cube. In the center of this particular cube. Now, how many corners will be there in a cube? Anyone? How many corners will be there in a cube? I have drawn the diagram. How many corners will be there in a cube? How many corners will be there in a cube? No, it cannot be 8. It should be 8, because we have to consider all the corners. 1, 2, 3, 4, 5, 6, 7, 8. So that's what he told. The valence electron will be occupying not even 6, it should be 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's where we have total 8 corners. Okay? Now, that's what Lewis told. So all those valence electron, it will be occupying the corners of this cube, imaginary cube. They will be occupying the corners of this imaginary cube. So depending on the atom, valence electron, respective number of corners will be occupied. Say for example, if I take sodium, okay, where atomic number is 11. All of us, we know how to write the electronic configuration. So I will use neon and I will make it as 3s1. That is for the sodium electronic configuration. Okay. Now this is the only valence electron present in the sodium. That means any one of these 8 corners will be occupied. Any one of these 8 corners will be occupied. Okay, so that's what Lewis has assumed, and therefore he told that an element wants to have 8 corners to be occupied. That's what he told. Elements wants to have all the 8 corners should be occupied. That is the intention of the element. Okay, that is the intention of the element. All of you are understanding? Okay. So what he is telling, he is talking about the kernel, that means a core part of the atom, or atom he considered as a positively charged kernel, which will be surrounded by the valence electrons. That means that positively charged kernel includes nucleus with protons and inertial electrons. Naturally, number of protons will be dominating, so it should be having positive charge, because we are not considering the valence electron. Okay, fine. So yes, Dikshit, very good morning. That's where we have the kernel surrounded by the valence electrons, and these valence electrons, that's where he assumed these valence electrons should be occupying 8 corners. It should be occupying 8 corners surrounding this particular kernel. Hagadre, when I am talking about sodium, how many valence electron? Only one. Only one valence electron. So that's where it will occupy only one position, any of these 8 corners. Only one position, because only one valence electron. So all of you have understood? So that's where Lewis, who came up with the idea of 8 atoms occupying the 8 corners. We are going to define, don't worry. Before that, I will explain the contributions by 2 people. One is Lewis and another person is Causal. So these 2 people have contributed in the initial stage. Okay, where Lewis now he has told that valence electron will be occupying the 8 corners. All of you have understood? Any doubt in this regard? Shall I move to the next one then? Okay. So therefore, he represented the elements. He represented the element, which we will call it as Lewis symbol. Which we will call it as Lewis symbol. So please remember, you can expect 1 mark question where they will write represent sodium by using Lewis symbol. Represent chlorine by using Lewis symbol. Okay, so that's where we have the Lewis symbol, which I will call it as important. Okay, which I will call it as important, not very important and all, just important. Now when I am talking about Lewis symbol, this particular thing is going to represent, element and its number of valence electron. Element and its number of valence electron. Okay. So what that Lewis symbol talks about, it deals with the element and number of valence electron. All of you have understood? That's what Lewis symbol talks about. Hagadre, if I want to write the Lewis symbol for sodium, Now what I will do, for example, I want to write the Lewis symbol for sodium. I will write it as Na with one dot. Because sodium is having only one electron, valence electron. Please remember, I am not talking about other electrons. I am talking only about the valence electron. And that's what Lewis symbol is going to deal with. It talks only about the symbol of that particular element and the valence electron only. Okay? So that's what the information will be taken by Lewis symbol. Okay? So sodium with one dot. Why? Sodium is having only one electron. Right? Sodium, as I have written earlier, if I want to go with electronic configuration, that's where I have only one electron. That will be represented by one dot. If I want to represent chlorine by using Lewis symbol, if I want to represent chlorine, now I should write it as Cl, symbol of chlorine. Then how many valence electron in chlorine? Any one of you? How many valence electron with respect to chlorine? Yes, Likita, absolutely correct. It should be 7 valence electron. Very good. Because it belongs to group 17. Yes, now all of you are right. It will be having 7 valence electron. So 1, 2, 3, 4, 5, 6, 7. So that's where I have the valence electron of chlorine, which will be represented by 7 dots. Which will be represented by 7 dots. So now observe here carefully. This and this will be considered as lone pair of electrons. Lone pair of electrons. And this is a lone electron. This is a lone electron, especially when they are forming the bonding. So we will call it as whichever is leftover electron which are present in pairs, they are called as lone pair of electrons, and whichever is present as a single electron, it will be represented as lone electron. But please remember, when you are writing Lewis symbol, all this mentioning is not required. All these labelings are not required. Just Cl with 7 dots, and please look at that. There should be 3 pairs of electron and 1 lone electron. Okay? Fine. So next one. Why 7 electrons with respect to chlorine? Because atomic number is 17. Atomic number is 17. We have to take the help of neon only. So we have to take the help of neon only. Right? Now, what should be the electronic configuration? Rohan. Okay, I am writing on the bottom side, that is accepted. Okay, upper side, upper superscript should be a mass number, atomic number should be written at the bottom. Okay, all of you have understood? Or you can write here, like right here, anything is fine. So that's where we have the neon. We will be take the help of the neon. Since chlorine belongs to period number 3, so it will be 3s2 3p5. 3s2 3p5. So how many valence electron? 7 valence electron. So therefore we have shown 7 valence electron. Bottom left or right, anything is fine upon. But normally we can go with bottom left. Okay. So that's why we have 3s2 3p5. So we have 3s2 3p5. Any doubts in this? Any doubts? That's why we have 7 valence electron. Okay. Now, if I want to talk about nitrogen, Lewis symbol for nitrogen. Okay. Now that's where I have nitrogen. How many valence electron in nitrogen? How many valence electron in the nitrogen? How many valence electron in the nitrogen? It will be 5. Yes, very good. The valence electron will be 5 because group 15 element. So 1, 2, 3, 4, 5. So that's where I have the Lewis symbol for the nitrogen. Okay, that's where I have Lewis symbol for the nitrogen. What I will do is first I will write the electron at all the corners, especially 4 corners. First I will write, and whatever leftover electron will be there, I will make it as a pair. So that's where I have the nitrogen Lewis symbol. Okay, 5 dots should be there. In that 2 dots are close to each other. Rest of the 3 they will be far from each other, occupying the 4 corners. Fine. 4 corners in the sense front view. So imagine that nitrogen. Okay. So that's where 2 here, 1 here, 1 here, and 1 here. So like that I have written. So that they should be far from each other. That's all. Okay, na? So that's where we have the nitrogen. Now can you write it for carbon then? Can you write the Lewis dot structure for carbon? So it will be like, when I am talking about carbon, how many valence electron in carbon? How many valence electron in the carbon? Anyone? How many valence electron in the carbon? Yes, there are 4 valence electrons. So 1, 2, 3, 4. That's where I have the 4 valence electron for the carbon, which I have written it as 4 dots, which are far from each other. Which are far from each other. That's what Rohan I am telling. So carbon can be written like this, where all the 4 electrons are far from each other. Okay. So all of you have understood? Here, why we have shown in pair? Because total 7 electrons, right, for chlorine. So 1, 2, 3, 4, 5, 6, 7. So that's why it became pair. Because there were excess electrons, more than 4. So therefore it went for pairing. Fine. So that's where we have the Lewis symbol for carbon. All of you have understood? Any doubts in this? Any doubts? So how to write the Lewis symbol? So the Lewis symbol for an element, where you should write first element, then you have to distribute the electron, total valence electron of that element in such a way that all the electrons should be far from each other. If any excess electrons are there, then it has to go for pairing. So that's where we have the Lewis symbol for the elements. Fine. Hagadre, what is the advantage of Lewis symbol? Why we have to learn the Lewis symbol? What information it will give? Okay, so what is the information which I am going to get from Lewis symbol? Very important information we are going to get is with regard to valence electron. With regard to number of valence electron of a element. Number of valence electron of a element. That is the information we are going to get it from Lewis symbol. All of you have understood how many valence electrons will be present in those particular element. Fine. So for one more question, Lewis symbol they can ask. Any questions related to this or any doubts related to this? Any questions? Okay. Now, you people were having a doubt. See, for example, I have X element. We can write atomic number, mass number. In some books, you will find atomic number, mass number. In some books, you will find atomic number, mass number. Okay. Now, one thing you should make sure that atomic number always should be written at the bottom. It can be left hand side or right hand side. Whether I am clear, mass number always should go at the top. Mass number always should go at the top. Fine? Whether I am clear with this? We have different ways to represent. But one thing is clear that atomic number should be written at the bottom. Fine? So, ಹಾಗಾದ್ರೆ next one. We'll move to the next one. This is with regard to Lewis. This is with regard to Lewis. Now we will come to causal theory. Now we will come to causal theory. Okay? Now, what Lewis talks about? Lewis talks about the element and its valence electron. And he told that all the element wants to have where all the 8 corners should be filled by the electrons. Okay? Now, that is extended by the causal. That is extended by the causal. Okay? So, now, what he told is, he told related to bonding with related to interaction, keeping in mind of the Lewis concept. Keeping in mind of the Lewis concept, further he extended with respect to bonding, interaction. Now, first point with regard to the causal theory. First point is, he spoke about the periodic table. He told that in the periodic table, PT means periodic table, but in your exam, make it full form. In the periodic table, highly electronegative elements and highly electropositive element, highly electropositive elements separated by inert gases. Separated by inert gases. Okay? Separated by inert gases or noble gases. Anything is fine. So what he told, in the periodic table, highly electronegative element and highly electropositive elements are separated by noble gases or inert gases. So which is highly electronegative then? Halogens. Which is highly electropositive then? That is alkali metals. That is understood. So here it is with regard to halogens and here it is with regard to alkali metals. Alkali metals. Okay? So that's what first point with regard to this particular theory. All of you have understood? All of you have understood? Now, next point. Halogens will form anions by accepting the electrons and alkali metals will form cations. by donating the electrons. By donating the electrons to attain the stability. To attain the stability. That's what the second point. So second point, what it tells? Second point tells that halogens, they are going to accept the electron, and due to that they will have the stability. And alkali metals, they are going to donate the electron to attain the stability. Okay, all of you have understood? Fine. So what is that stability? That's what he will be pointing it out in the second point, in third point. So what is that stability? Okay. These elements, which are those elements? Halogens and alkali metals. These elements will attain the stability by having 8 electrons in the valence shell. By having 8 electrons in the valence shell. In bracket you can write it as octet state. Octet state. By having 8 electrons in the valence shell. That is octet state. Fine. All of you have understood? Any doubts? Okay. Now, last point here is electronegative or anions. Electronegative is not required. It's understood. Once again, I will not write. Anions and cations. Anions and cations will have electrostatic interaction. Will have electrostatic interaction. Will have electrostatic interactions. That will be the last point. Okay. So what is that causal theory talks about? He talks about bonding, keeping in mind of Lewis concept, that is 8 corners. Okay. Now he told that in the periodic table, highly electronegative element, that is halogens, and highly electropositive element, that is alkali metals, are separated by inert gases. That's what he gave, postulated. Next one, halogens will form anions by accepting the electron. What do you mean by anions? Negatively charged ions. So anions will form, halogens will form anions by accepting the electron, and alkali metals will form cations by donating the electron. So what do you mean by cations? Cations means a positively charged ion. So by donating the electron to attain the stability. So that's what he told. In the next point, what is that stability? These elements will attain the stability by having 8 electrons in their valence shell. That is octet state. 8 electrons in their valence shell. If you remember, that's what Lewis, 8 corners with 8 valence electrons. That's where 8 electrons in their valence shell. And the last point, whatever anions and cations which are having 8 electrons in their valence shell, they will be stabilized by electrostatic interactions. They will be interacting with each other by electrostatic interaction, because one is positively charged and another one is negatively charged. Okay? So all of you have understood? Sir, it is important from exam point of view. Not much important, but try to understand. Okay? All of you have understood? That's where causal theory talks about. Causal theory talks about. Any doubts in this? Any doubts from this point of view? So, what is that causal theory talks about? It keeps, or it is related to Lewis' point of view, or it is related to Lewis' theory. And to extend that one with respect to chemical bonding, he has given some of the postulates. And in this case, he is talking about ionic compounds. It's talking about ionic compounds. Okay. Now we will go with one example to understand the causal theory. We will go with one example to understand the causal theory. But any doubts in this particular points? There may be some variation, whatever is there in textbook and all, because I will be writing these statements in my own words, but concept will be same. Okay, now? Now we will come to examples. We will come to examples. So that's where we are getting the answer for this. Why bonding is necessary, which is much answered by Lewis and Causal. Okay, so now we are going with the example. I have sodium with atomic number 11. Okay, with atomic number 11. So as we know, electronic configuration will be neon 3s1. Okay, now in reality, if I don't write the neon, then the electronic configuration would have been 1s2, 2s2, 2p6, 3s1. All of you will agree? If I don't go with the neon, then I should write it as 1s2, 2s2, 2p6, 3s1. All of you will agree? Now, same way, if I go with the chlorine, where where atomic number is 17. Now, same way as that of the sodium, I should take the help of neon, because chlorine and sodium, they belongs to same period. That is period number 3. So therefore, I should take the help of neon. Then I can write it as 3s2, 3p5. So 3s2, 3p5. Now, if I don't want to write neon, then I should write it as 1s2, 2s2, 2p6, 3s2, 3p5. Okay? So this would have been the electronic configuration for chlorine. All of you have understood whatever I have written on the board? So that's where we have the electronic configuration for sodium and chlorine. Okay, that's where we have the electronic configuration for sodium and chlorine. Now, if you observe it carefully, sodium can have the octet state. Sodium can have 8 electrons in their valence shell. How? By losing 1 electron. If it loses this 3s1, then left over will be 2s2, 2p6, 6 plus 2, 8. Right? So that's where I can have Na plus, atomic number will be same, no doubt. Now neon, it will become, no neon. Now it will become neon, that's all. It has attained the electronic configuration of neon. Or I can write it as 1s2, 2s2, 2p6. So here I will mention it as 3s0. So that means sodium, by losing 1 electron, it will attain the electronic configuration of neon. That is 1s2, 2s2, 2p6, because 1 electron of 3s has been removed. 1 electron of 3s has been removed. That's where we have 1s2, 2s2, 2p6, which will become Na plus. All of you have understood? Same way, when I am talking about on the other side, now chlorine can also attain the octet state. Okay? So chlorine can attain the Octet state, that is by losing the 7 electrons. Okay, so that is one option. That is by losing the 7 electrons. Now what will happen? Now chlorine, when it will lose the 7 electron, it will attain the neon electronic configuration 3p0. So these 7 electron it has lost, or we can write it as 1s2, 2s2, 2p6. Got my point? That is one option for chlorine to have the or to attain the inert gas configuration, that is 8 electrons in their outer shell. For chlorine, it is possible when it will lose 7 electrons. That is one option. Another option here is it can take up 1 electron. It can take up 1 electron and it will become now chlorine 17 only. It will become minus and it will have the electronic configuration of argon. It will have the electronic configuration of argon. That means, so 1s2, 2s2, 2p6, 3s2, 3p6. 3p5 will become 3p6. Got my point? That's where I have chloride, which will have the electronic configuration of argon. So therefore we can tell chlorine is less stable compared to chloride. Sodium is less stable compared to sodium plus. Now I will come back to here. Now if I consider this one as a first option and this one as a second option, which one chlorine is going to prefer? First one or second one? You can just mention one or two. Which one it's going to prefer? First one or second one? In both the cases, it will attain the inert gas configuration. In second one, it will go for neon. In first one, it will go for argon. Yes, it has to go with first options because removing the 7 electrons is a difficult task. Right? If you remember, chlorine is an electronegative element. Chlorine is an electronegative element. Okay? So removing from this 7 electron, that means very, very high energy, that is ionization enthalpy will be involved, which is not at all possible. Right? Very high amount of energy is required. So naturally, second option, chlorine will never go with second option. Second option is not at all there, it is ruled out. Always it will go with the first option. Okay? So where it will take up 1 electron and it will attain the electronic configuration of argon. And that's where we are going to get Na plus, and that's where we are going to get Cl minus, which are interacting with each other by electrostatic force or electrostatic interaction. So positive and negative ions, always they will interact with each other by electrostatic interaction. All of you have understood this one? Any doubts? Now due to that, now I can tell that Na plus is stable compared to Na, Cl minus is stable compared to Cl. Why? Because Na plus, that means it has attained the neon inert gas configuration, and Cl minus has attained the argon inert gas configuration. Fine? So in that case, shall we move to the next one? Okay, Rakesh. Then in that case, that's where causal theory talks about. That's what he told. Alkali metals, they are going to lose the electron, and halogens, they will take up the electron. And finally, we are going to get cation and anion, which will be interacting with each other by electrostatic force. Okay? Now, during this losing and gaining of electron, they have attained the inert gas configuration. They have attained the inert gas configuration. That's what causal theory talks about. Fine? This is a very important topic. Please inform to your friends to attend the class. It's very important topic. Okay, na? All of you have understood? Any doubts in this? So that's where we have come to Lewis causal theory. Lewis causal theory, which can be called as electronic theory for chemical bonding, which can be told as electronic theory for chemical bonding. Electronic theory for chemical bonding, which is also called as Octet Rule. Which is also called as Octet Rule. Okay, which is also called as Octet Rule. What it tells? It tells that an element is going to interact with another element to have the 8 electrons in its outer shell. What is that it talks about? Element or elements will interacts with other elements, which can be same or different. Other elements, I can write it as same or different, to attain the octet state. So what is that octet state? That means any of the inert gas configuration. That is 8 electrons in their outer shell. So that's what octet state meaning. Now you got the definition. So now we got the answer for why bonding is necessary, or why bonding will be happening, or why an element is going to interact with other element. Here interaction is nothing but bonding. An element is going to interact with another element is nothing but we are dealing with the bonding. Okay? So that's what elements will interact with other elements, which can be same or different element, to attain the octet state, or to attain the inert gas configuration. Okay? So how they are going to attain? That can be either by sharing of electron, or losing of electron, or gaining of electron. How this octet state can be attained? Either by sharing of electrons, losing of electron, or by gaining of electron. Yes, Stefan, that is enough. So elements will interact with each other or with other elements, which can be same or different, to attain the octet state. Now, if you want to extend, then you can mention, this is enough. If you want to extend, you can tell that which can be attained, which can be reached by sharing or losing or gaining of electrons, which can be attained by sharing, losing or gaining of electrons. Fine. So that's where we have the octet rule, or electronic theory for chemical bonding, or Lewis causal theory. Fine. Any doubts in this? If you have any doubts, you can raise the question. This is where we have Lewis causal theory. That's what octet rule talks about. Normally it will be called as octet rule. Okay? So in your exam they will ask, what is octet rule? Then you should tell that it talks about interaction of the element to attain the valence 8 octet state. Which can be either by sharing of electron, or by losing of electron, or by gaining of electrons. That's where we have the octet rule. In short, we can also tell that to attain the inert gas configuration, because other than the helium, among the inert gases, other than the helium, all the other elements, they will have 8 electrons in their valence shell. They will have 8 electrons in their valence shell. Fine? Any doubts? I think it should be a holiday, appa. There will not be classes. It will be a holiday. Rakesh. Okay? Any doubts? Okay, then. Thank you. So you can practice with periodic classification of element, because you have Sunday tomorrow. Then you should read whatever we have discussed today. Okay? Manjunath. No sir, you have written sit, but what is that no sir? What you wanted to tell? Okay, thank you. Bye. That one has not come. Test today. Yeah. All the best. Do well in your test. And I am confident your performance will be good. Okay? So bye. And I think that might be the reason attendance is a bit less today, but I don't know. Okay, fine. Thank you, Appa. Take care. All the best.